Example 1, determine the exact value of sine theta, cos theta, and tan theta for angles whose terminal arm pass through the point 3 and 4. So we're finding the ratios. You're not actually finding the specific angle. We can talk about how you could do that. An exact value means you want to leave your answer as a fraction. So you don't use a decimal. These would be non-calculator questions, so you wouldn't want to find that anyways. So I'm going to draw what picture this is, what quadrant this is in. So I'm going to draw an X and Y axis here. And this is the point 3, 4. So it's actually in quadrant 1. I'll actually even draw little tick marks in since there's not that many. You don't have to draw it always perfect here, but 3 and 4, that's small enough numbers. And I'm going to draw a point going through there. So this is the point 3 and 4. So from there, I want to draw it's called a reference triangle. So I want to have it include the reference angle. So the reference angle is to the nearest x-axis. So I draw this down to the nearest x-axis and I make a right triangle. So I'm going to put my angle symbol in here. I sometimes just use this symbol in my reference triangles, so I'm not kind of mixing up theta and theta r because it can kind of sometimes get confusing. So let's label. This distance here would be a distance of 3, since this is 3 on the grid, and up would be a distance of 4. Now we want to find our ratios. Well, for sine and cosine, we're going to need hypotenuse. So to find hypotenuse, we're going to use Pythagoras theory. C squared is equal to A squared plus B squared. Or if you wrote A squared plus B squared equals C squared, of course, that's the same thing. So C squared equals, we're going to plug in 3 squared plus 4 squared. Doesn't matter if you put 3 or 4 first in terms of which one's A and B. So 3 squared is 9, 4 squared is 16, so C squared is 25. Square root that, and you have a distance of 5. So this is a distance, I'm just going to put in another color because that's what we found, of 5. Now, some of you maybe, that looks kind of like an S. There we go. Some of you maybe are recognizing this as a 3, 4, 5 triangle. We use that in math a lot as just some nice simple numbers to use. All right, so let's write our ratios. Sine theta is opposite of our hypotenuse, so we can just look at the diagram, 4 over 5. So you leave this as an exact value. You don't need to write that as a decimal. So that's your answer there. Cos theta is adjacent of our hypotenuse, so it's 3 over 5. And tan theta is opposite of our adjacent, so that is 4 over 3. So those are my answers. Now, you may be asked in some questions, if you have a calculator, what the actual angle is. So note, to find the angle, you would use a calculator. And it doesn't matter which ratio you pick, you'd get the same answer. And you use that sine -1. So depending on your calculator, it's kind of usually in the top left-hand corner of your calculator. It'll say second function or shift a lot of the times. And then you put 4/5 in. You most likely need brackets around it. Often a calculator will open a bracket, in which case you need to close it. It's always safe to put them in there. And so you put that in your calculator. I don't have a calculator right beside me to show you, but you can try that on your own. When you do that, we want to say this is how you find the reference angle. And just in case you've got your calculator handy, 53.13 degrees. So we will be doing some calculator work a little bit later on. But just so you even understand the difference between a ratio is just the fraction, whereas finding the angle will be taking it the next steps using your calculator and actually finding this distance right here, 53.13 degrees.